Well, this is Algebra 2 and Integrated Geometry, preparing the classes for pre-calculus next year. Now we are going to conclude Chapter 7, a very powerful application, and that is 7.7, how to apply the exponential and power functions. Just to review with you that we learned this from Chapter 2. When you have a function y equals mx plus b, and that's a linear function, there's a straight line, either increasing or decreasing, or it is a horizontal line. And over here, before I move into here, look at this, which means that x cannot be 0, okay? Because if x is 0, then you just have a horizontal line. Now, we have dealt and we've learned a great deal with exponential function. Y equals a times b to the x, okay, power. And you see that b, in this case right here, cannot be negative and it cannot be 1, okay? So you see that the graph of this exponential function right here, it is forever increasing or forever decreasing. Remember that, right? When you graph that. Now comes into the power function. I want you to see the difference. This is y equals a, b to the x. This is y equals a times x to the b. So in this function, what's the difference? Well, look at this. This is the graph forever increasing or forever decreasing. In this case right here, you see that depends on the power, the number, the value for b. X to the power b. If b is even, then you have that's right, a parabola. And if it's, a higher degree, even like 4 or 5, it could be increasing and then decreasing, and then it, the concave up. So this could be increasing or decreasing. It depends on the value of the exponential b, and that's the power function right there. All right, now in this 7.7, we are going to learn how to write these two functions right here from a given data, which is given points of x and y. Remember, we all need 2 points to write the function in all of these, 3 functions. Okay, so look with me in your example. Suppose you have a function right here. This is the exponential function y equals a times b to the x. All right. Now, if you are given 2 points that this graph crosses 2, and that is 1 and 12, that's your x, that's your y, and it crosses another point which is 3, and this is 108. All right, ladies and gentlemen, how do you graph this function? How do you write the exponential function, knowing that the graph of this y equals ax, a times x to the b, x goes through these 2 points. It crosses those 2 points. So your job is you're going to find a and you're going to find b. Just like linear function, you're going to find a and you're going to find b. Okay, so you set up the first function. Plug in this value for me. Plug in right here. And remember, this is just x and that's the value for y. Okay, so plug the first point into this. So you're going to have, remember, 2 sets of function with 2 variables so you can solve for them. So look right here. Plug in, you have 12, and that's y, equals a and b to the x. X is what? X is 1. So technically, you just got that right there for me. Okay? So now what you have right now is just solve this for a so you can do substitution in a simple form. And that what you have in your first point. Okay? So let's use the second point. Second point right here. This is your x and this is your y. Plug this in. What you got? You will have now 108, okay, equals a times b, and b is what? B is 3. There we go. Okay, so now I'm just simply rewrite this in form, solve this for a for me. A equals 108 over b to the third. Okay, why do I do that? Because I see that both a, okay, if this is a curve, they're going through this, so both a will have the same value right here. Therefore, I am now doing what is called substitution. If a equals this and a also equals this, therefore these two must be, same value. So you got 12 over b, set them equal to each other because they both have the same value with a. So 108 over b to the third. Now look, can I just go ahead and divide both sides by or time with 1 over. I see something right here. I'm going to divide both sides by 12. Is that okay? Or time both sides with 1 over 12 because I'm not solving for b. So look, time both sides, okay, with 1 over 12. So I get distributive in, you got that right there. And time this in, you got 108 divided by 12. You got what? You will have 9. That is correct. So look, so after you time 1 over 12, both sides you have right now is 1 over b equals 9 over b to the third. Okay, notice that right there. Makes sense? So look, how about I time another b? Okay, of course this is b cannot be 0. So I'm going to time, because I got b and a b third, I'm going to solve for b. So I want to get rid of b over here. So I'm going to time b both sides. Okay, so now look, just to give you a picture right here. Okay, so I will now time what? B to both sides. You do the same thing to both sides. You have not changed anything. So time in, you got what? You got 1. There we go. B, that's simplified. This and that will give you 9 over b with the b third, you got b squared. There we go. So what would be the value for b? Well, bring b up here. You got b squared equals 9. Then it means that b equals plus or minus 3. Correct. But you know already, this is an exponential function, therefore b cannot be negative. So the value is 3. That's it, guys. Okay? All right, just that concept right there, capture that. All right, now you can plug it in and you can just check the value is the same as there. All right, now you have b. b is 3. Well, we're not done yet, Mr. Dan. We have now is b. So far you have is a, b. Now b you have is what? Yep, 3. 3 to the x. But then what is a? Okay, now you have b already. Either point, okay, you plug in, you can just find, but then just use this point because the number is small. Look, you have a is expressed in terms of b. So if b is 3, can you plug b3 in for me? Yep, plug b3 in. Then what is a? Yeah, 12 divided by 3, that is 4. So a is 4. Ladies and gentlemen, we got everything. 4 times with that right there. So there we go. That is your exponential function from given 2 points and the exponential function right here, and use the substitution for a and b, and then you solve, and then you got the value for a and b, and the task is done. All right, now let me move now to another form of exponential function, and that is this right here. In your next example, you will see, and that is, what if you transfer the linear function into the exponential function, okay? What if you have right now, turn with me to the next page. You see that, okay, to find an exponential function, to find this one, y equals a times b to the x. And then this exponential function, look at this, a set of more than, suppose you have a value for x and y, okay? You plug it in, you got certain value right there. And by looking at this set right here, you know that it is not a linear function. Because if you plug in the value, you see that these values right here are not. They are not fit into, let's say, a straight line. So it comes from an exponential function. So how do you find the function? How do you find function from a given value of x and y? This is called, the transforming exponential data. Okay, so here we go. It says that a set of more than 2 points x and y fits an exponential function if and only if the set of transformed points x and l and y, this x and l and y, is a linear form, which is the linear form, and you know that already, and that is, it can be written as y equals mx plus b. All right, it's a little bumpy right here, but I will give you the example and you will see this. Okay, now look with me into example 1. Example 1, they give you the set of value of x and y. And that is 1, and this is 12. This is 2, and this is 16. This is 3, and this is, let's say, 25. Just exactly as the book has, okay? 4, and this is 36. And look at this right here. You see that, Mr. Jang, this is not a linear function. If you put into the grid, it's going to be a curve. Or can I find Can I find the function that express this one right here? Or happily, we know that this guy come from what? Come from the another data pairs, and that is the data pair is right here, and that is x ln y. There we go. Okay, this is x ln y. Your y value right now is ln y, and the x remain the same. So to find the value for a and b, you have to right now plug back into another set of value of this guy. So this is x, this is ln y. There we go. This one right here, when you plug the value in, this one, the graph of this guy has to be a linear function, mx plus b, which is, it fits all the point in here. It fits almost close to a perfect straight line, a perfect line, okay? So using calculator, plug in for me. X is 1. Okay, what is ln of 12? Plug in. ln of 12, you got 2.48. There we go. The next one, if add x is 2, and then what is ln of 16? Plug it in. You got 2.77, okay? And then so on. I'm going to use another point, and then that will conclude. How about x is 7? Okay, if x is 7, you plug in. Y of 7 would be, ln of y, which is ln of 7, is 4.56. Okay, you will graph this one. You will see it fit into a function. Graph this guy, you will see that it looks like this. There we go. And all the point, it fits right there. So to find the value for a and b, coming from the source right here, well, how do you know that? So you have to know the value right now. How do I find the exponential form from this guy coming out from that guy? So look, this is a little bumpy, as I told you. The example is on page 530. I'm going to work this out for you. You need to find the form of this guy first. Y equals mx plus b. Okay, so let me erase this. Okay, all right. There we go. First, we know that if this one fits into a linear function, then you can use the linear function to rewrite this back into the exponential function. What do I mean by that? Using this linear function, I'm going to write the linear function, okay? Let's pick 2 points, and these are my 2 points right here. And you guys know that I told you from the beginning, to write the linear function, if you know that the line, the graph crosses 2 points, then you can write that. First, you need to find the slope. Okay, it's not hard. M equals what? Y2 minus y1 over x2 minus x1. That's my slope right there. And then you use the point slope intercept to write the function. Let's use this is your x1, okay? This is your y1, x2, y2. So let's find slope. M, find slope. y1, y2. This is your x1, this is your, x1, y1, x2, y2. Okay. Oh, this is 1. Sorry, this is 1. Okay. All right. So here we go. All right. So use y2 is 4.56 minus y1, which is 2.48. There we go. Over. Okay. Over. Clear this one so you guys see now, right? Okay. So over what? Over, that is 7. Okay. 7. There we go. 7 minus 1. So guys, you get that right there, right? Okay, so using this point right here, plug in, you will get the number around point 35. There we go. So now you have the slope, guys. You have the slope. So can I use the point intercept slope right here? Okay. So let's use the first point. Okay. So the slope, you have take what? Y minus, okay? Y, and the y of this point right here is this. This is the whole y. That's x, and that's the whole thing right here is y. That's your y right there. So your y right here is ln y. Got it? So look, I'm going to write this into the linear form, which is now using this right here. Y minus, okay, using y minus the first, which is ln y, okay? All right, and ln y right here is what? This point right here is what? That is the point right now that is use red ink, 2.48 equals the slope. Slope is right here, 0.35 times with, remember, right here, which is x minus what? X minus 1. That's how you write the function right there, okay? So now you have the y, but the y right here is the ln y, just to give you a little bit of the taste. What is your y? Right here is the ln y. There we go, okay? All right, now you just have the linear function in terms of a logarithmic form. So now you are going to rewrite them back into this form right here. That's going to be a fun thing to do, which is you solving for y, okay? Now look, I am going to bring this 2.48 over here, okay? I'm going to do that and just let's solve for ln y. So let me use this one. So ln y right now, bring this over, you will have, look, I'm going to distribute this in, okay? And that is 0.35x. That would be negative 0.35. And then this one right here, bring it over, you will get positive 2.48. Okay, you see that, guys? So now ln y equals 0.35x, and this and that together, you combine that, you will have right now is, that is correct, that is plus 2.13. Okay, now guys, I'm gonna solve this for y right here, and the a and b already appear right there. So how do I solve this for y? You are no stranger to this. Natural ln y equals this. To solve for y, you take e both sides. There we go. You are now the expert of that. Take e both sides. If you take e on this guy right here, what would that turn into? Yep, e to the ln, the base e right here. So whatever that is, you just got y right there. There we go. Now look, this one is coming out from the property of exponential properties. E to a plus b, and that is, rewrite this for me as this form right here. Look, e 0.35x, okay, plus with that meaning time with e to the 2.13. There we go. Okay, you guys see that? This is equivalent to that right there. Remember from the property of e to the m plus n. This is same thing as e to the m times e to the n. That's the property we learned a long time ago. So now look at this right here, guys. Use your calculator, okay? E to the 2.13, you have a value, and that is it's 8.41 because e is 2.7. So now you have everybody you need. E to that will give you 8.41, and then keep this in the form that is desired, which is right now you have here. You want to keep this right here. You can say, oh, Mr. Zhang, what is e to the, you know this, guys, look at this, same thing as this right here. It means that e to the 0.35, and then the whole thing to the x. That's what the property is. You see that? Exponential of exponential will get you there. Then what is 2 to the power of 0.35? Well, that will give you 1.45, okay? So that now you can have this right here times with 1.42 to the x, which is right there. Guys, that is a pretty cool thing to convert from a given data and check out the linear form of a logarithmic form, and then you now have the function. This is expressed right here. Your a is right here, that's your a, and your b is right there, and that's x right there. Okay. That's just, I worked out in details for you to see that this is an exponential model coming out from a given data, and that data must fit into a linear form. Okay? All right. I'm going to move into the next example and give you the exercise how to write the power function. All right, go to the next video, guys.